Okay, so the video camera is recording again. Here I go and sit down for you. Okay, so we've made our model, and hopefully you have a model too if you're doing this along with me. Otherwise, that's okay. You can watch and see how this all works. And so we have our model. It should look like this with the equator going around and the northern and southern hemisphere. Now, the other thing that we need to talk about right here is the stick that goes. Do we really have a stick going through the middle of the earth? No. However, this kind of shows you, kind of gives you a model of what's going on, so you can kind of figure out how things are moving in the earth. So, anyway, we put the stick through the middle to act as the axis. Okay, so we have the axis going through the center of the earth. Now, if you hold your ball just like this, it'll probably look similar to mine, unless you have an orange, or somebody mentioned an apple yesterday. Maybe you have an apple with a line going through it and a stick going through the top and bottom of it. So so the stick represents the Earth's axis, and when we're talking about day and night, we're talking about rotation. We're talking about the Earth rotating around on its axis. Okay? So this is just kind of an example, and I actually brought a light out here so you could see. And you already know that the light that's shining on the part of the Earth has daytime, and then the side that doesn't have the sun shining on it is night. Okay, you already know that. I think you have that pretty solid in your mind. And the Earth goes completely around its axis one time in how many hours? Right, 24 hours. So you already know that there's 24 hours in one complete rotation of the Earth. Okay, so I'm going to turn the light out for a second and go back to my directions and what I'm supposed to do for this investigation. Okay, so we have our axis, and we have completely rotated around one time at least. You might have done it a few more times than I did, but that's okay. And I'm going to turn that paper over. Now, you're supposed to notice how the ball turns around. That's what gives us day and night. But it has nothing to do with the seasons. So Ms. Boundsman, you already talked about day and night. We've actually already talked about seasons. But this investigation will help you really see it, okay? So, on the next lines on this paper right here, I want you to write down, pause the video, and write down what you already know causes the seasons, okay? So I'm going to go ahead and write what I know causes the seasons. No, I'm not writing anymore. I want you to write. Okay, so hopefully you wrote down what you think causes the seasons, and you have pressed play. Now, we've so far been holding our ball with the stick going straight up and down. Do you think that's typical of the Earth? No, it's not accurate. So what we're going to do is we're going to tilt the ball, the stick toward us, okay, so that we can see a really good view of this northern hemisphere. All right, I can see almost the whole northern hemisphere from this vantage point. Okay, so it's tilted toward me. And it should be tilted toward you on your hand at your house, okay? So now the top stick is nearer to me than the bottom, and that's how the Earth is in space. Okay, so it should look like this. Now, you notice how the top half, this northern hemisphere, since it's tipped toward me, I can see more of it. All right? Now, the next thing that we need to think about and to sort of prove with our investigation is how direct light produces more heat, so that you understand that the light from the sun that produces the heat that we have on Earth, the more direct sunlight hits our Earth, the warmer it is. Okay, so I need you to understand that. Okay, so to do this, we are going to put our globe down for a little bit, our ball down for a little bit, and we're going to do the rest of this part of the investigation. So you'll need a ruler.